Alright, so today we're going to be talking about lipids. Lipids are categorized as fats and oils or triglycerides, steroids, and phospholipids. These are the understanding of this unit, so you can just pause the video and look over it to make sure you know what we need to know for this unit. Alright, so let's first focus on triglycerides. This is what a common triglyceride looks like. It has 3 fatty acids, a glycerol attached, and when you make a triglyceride, you get 3 H2Os. This is because it undergoes condensation reaction. So undergoes condensation reaction. So if you look at it right here, we have our 3 fatty acids. We have a carbon, a double bonded O, and an OH, and we have a glycerol right here. So now when we want to combine the two using condensation reaction, we combine this H and this OH to make 3 H2Os. And we learned condensation before in the unit. So now let's look at the types of triglycerides. So let's first look at this first structure. This is a saturated fatty acid. So when we look at saturated fatty acids, we can see that it's just all single bonded carbons with a carboxyl group right here. Now, when we look at the other kind, unsaturated, these are unsaturated fats. Unsaturated. There are 2 types. There's this right here, and right here. This, and what makes an unsaturated fat is this double bond right here, and this double bond right here. So if you look at it, there's 2 hydrogens going this way on this side, and 1 hydrogen going this way, and 1 hydrogen going this way. So this is called a trans fat. It's called a cis fat. So the reason that this right here is a trans fat is because the hydrogens are pointing 2 different ways. This is called a cis fat because the hydrogens are pointing the same way. And a good way to remember this is cis same. So, the hydrogens are facing the same way. So we learned that through condensation reaction, you can form a triglyceride. So to break a triglyceride, you use a hydrolysis reaction. This is when you put water in, mix water with a triglyceride, and then with an enzyme called lipase, which is secreted in the pancreas, the triglyceride breaks into 3 fatty acids and a glycerol in the small intestine. So this can happen with a strong acid or a strong base. If you're using a strong base, then you need NaOH and heat. Okay, now let's look at rancid fats. So you know when sometimes you see a fat, when you see like food and it has like a bad smell, texture, or appearance, there are 2 causes for that. There is hydraulic rancidity and oxidative rancidity. So for hydraulic rancidity, it's a hydrolysis reaction with water, which we just discussed, or oxidative rancidity. Unsaturated fats plus oxygen. So it can't happen with saturated fats because saturated fats are a lot more stable than unsaturated fats because of that double bond. If you mix it with oxygen in the air, the atmosphere, you get an aldehyde or ketone. To prevent this like foul smelling substance, you can use antioxidants. Alright. And then let's look at the second type of triglyceride, phospholipids. So you can see here, there is a hydrophilic head and a hydrophobic tail. Hydrophilic head because not all lipids are non-polar, or they're all not soluble in water. This half of it is hydrophilic and half of it is hydrophobic. So the hydrophilic head is made up of glycerol and phosphate groups, and the hydrophobic tail is made up of 2 fatty acids. So if you look at this structure closely, you have the phosphate group right here, and then you have the glycerol group right here, and then you have your 2 fatty acids. So you can see here, this right here is a saturated fatty acids because they're all single carbon chains, and this is unsaturated because of this double bond right here. So if we go, after phospholipids, let's go back and see how to calculate the degree of unsaturation in fat with iodine. So if you look at this structure right here, let's just make that a little bigger. So if we see, we have a C here, double bonded C, H, 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 and H. So this, we can use an addition reaction. So you add iodine, and then you get your iodine. So to calculate the iodine number, for example, you have linoleic acid, which is C18H32 and O2. and you have to determine the iodine number. So what we have to figure out is 2 moles of iodine is going to react with 1 mole of 1 mole of linoleic acid. Alright, so we know these two things. And then if you figure out the molar mass of linoleic acid, you know that it is linoleic acid is 280 grams per mole. And then the molar mass of iodine is 254. Wow, that was really bad. 254 grams per mole. And then because there are two iodines, we also multiply this by 2. And then we get 508 grams of iodine. And then to calculate the final iodine number, we're going to say that 100 grams of linoleic acid reacts with it. So you do 508, which is your iodine number, grams, times 100, the grams of linoleic acid, over 280 grams, which is what you got from the molar mass. And then you get 181 grams of iodine. So your iodine number is equal to 181. So that right there is your final answer. Alright, now let's go to our